Welcome this afternoon to geometry class. I hope you've had a good day so far. And this one is another one. It's not really that hard, but it's very different. You're not used to some of these things. And so I wanted to run over them with you just because they are something that I don't think you've done very much with. We're dealing with matrices here. We've done a little bit with I don't know how much we've done with matrices actually in this class. I'm trying to remember. I don't remember seeing them before. These are transformation matrices. And they start out by showing you a matrix. A matrix is simply, they call it an ordered rectangular arrangement of numbers. And that's what they give you as introduction to this. They start out by adding them. And adding matrices is actually very, very easy. You simply add the corresponding squares. So in this case, 2 plus -1 is 1. 3 plus 4 is 7. 0 plus 3 is 3. -1 and 0 is -1. When you're adding matrices, you just add the corresponding cells. You cannot add two matrices unless they're the same shape. Matrices can take a lot of different shapes. Now, in the context of geometry, they're using this as a different way of writing the coordinates. So this is a rectangle. I have a horrible time on my computer getting a good rectangular shape. But anyway, you can look in your book on page 648 and then continue with me on to page 649 as we go through these next couple of slides. But anyway, so this is a rectangle, and you have the coordinates there, the coordinates for it. We can put those coordinates into a matrix. So you'll notice the first column is 2 and -1. That's the top point. Second point is 5, -2, and you see the second column is 5, -2. Third column, 3, -5. That's the third point. Fourth point is -1, -3, and the fourth column is -1, -3. So the first row is all the x's, second row is all the y's. There are some situations where this is actually fairly useful. The one that they're using it for is for transformation. You'll notice this is what the title is, transformation matrices. So, all right, here is a line with the coordinate points on it. So we can make a matrix out of that. And so, again, first point, 1, 4, first column. 5, 2 is the second column. X is in the first row. Y is in the second row. And we're going to add to that what is called a transformation matrix. And the transformation matrix in this case is 1, 1, 1, 1. And if we add that, then we're going to get 1 plus 1 is 2, 5 plus 1 is 6, 4 plus 1 is 5, 2 plus 1 is 3. Now we have new coordinates, so we can graph those new coordinates, and you'll notice this line's been shifted up 1 over 1. Okay, that's it. That's really all we're doing. We're using matrices to shove shapes around on a graph. I didn't draw the graph because you don't need that. You can look in your book, but I do want you to get the idea, okay? All right. Here we have a triangle. So we are going to give it a matrix. Again, first point, 1, 5, second point, 3, 5, third point, 1, 2. First row is the x's, second row is the y's. First column, first point, second column, second point, third column, third point. Here we have a transformed triangle and its matrix. Okay, so it now is at 4, 0, 4, 3, 6, 3. I'm sorry, I should say 4, 3, 6, 3, and 4, 0. First, second, and third columns of the matrix. And the question is, what was the transformation matrix that was added to the original triangle to get the second triangle? Okay? In other words, how was it transformed? What was done? Now, you might actually be able to look at it and go, oh, duh, that's fine, but we're going to learn how to do it using matrices, okay? So now we have the same two triangles with the transformation, and what we're going to do is to subtract the first matrix from the second matrix, okay? We're subtracting new versus old. This is the way we do it in physics all the time. When we have a delta, we always do final minus initial. Well, that's what we're doing here. We're doing the final triangle minus the initial triangle. And the question is, okay, so what is the transformation matrix? We've just done some algebra with the matrices. If you go back to the last slide, you can see that we're just rearranging the matrices algebraically. We subtracted this matrix from both sides, and that gives you what changed. And we can see that it was shifted down 3. Yeah. Yes, shifted right 3 and down 2. Excuse me. Sorry, confused myself. So shifted right 3 and down 2. So that gives us our transformation matrix. Okay, that's it. It's not a big lesson. It's not really horrible, but you do have to get this concept of converting the points into the matrix. And I thought maybe I wanted to talk you through that. So, all right, have a good lesson, guys. And hopefully we'll have some more fun in geometry next week.